So think about this. That is something that you could not have just easily predicted. It's a very strong result, but it is not something that you say intuitively, oh yes, of course. It follows immediately from the conservation of mechanical energy. So if I release it, that 2.5 radius point, by the way, is somewhere here. So if I release this object way below that, it will not make this point. Let's do that. You see it didn't make it. I go a little higher, didn't make it. I go a little higher, didn't make it. Go a little higher, still didn't make it. Now I go to the 2.5 mark, and now it makes it. 2.5 times the radius. Conservation of mechanical energy tells you that that is the minimum it takes to just go through that point. Of course, if there were no loss of energy at all, if there were no mechanical energy lost, that means if there were no friction, then if I were to release it at this point, it would have to make it back to this point again with 0 kinetic energy. But that's not the case. There's always a little bit of friction with the track for one thing, and also of course with air. So if I release it all the way here, you will not expect that it will bounce up all the way to here. It will probably stop somewhere there. It may not even make it to the end. We can try that. Oh, it made it somewhere to here. It's a little lower than that level, because there is some friction that's unavoidable.